Okay, in this video, I'm going to talk about linear actuators. So we looked at motors, which give you rotary motion. Linear actuators, on the other hand, gives you linear motion. So linear actuators, the term can be a little bit confusing because there's a lot of different variations of what people count as a linear actuator. You'll see linear actuators that look like this, which is essentially a push-pull motion of a rod. There's a rod here that can go in and out, and you can see that if you read this, it says move loads with consistent, repeatable push-pull motion. These actuators hold their load in position even when power fails. So that gives you a little overview. And then if you click on one of these, you could see how that looks like in more detail. This one is the connector. Yeah, I meant to click this one here. So see, this is a linear actuator, and then sometimes there's like a motor here, and then maybe some sort of gearbox, for example, that might actuate this. So you can see some images here. This is like a yeah, this shows you how some of the inner workings of how that one works. And we'll have other videos that go into details of this, but for now you can see that there's essentially a motor and some gearing and a lead screw, and then that allows this part to go back and forth. Okay, so that's like one variation you might see. You might also see like a positioning slide. This is where the motor is in line with the main um, screw that allows the slide to turn and move linearly. So you'll probably see those two as the most common ones. And again, the inner workings of this, we'll get into more details of that later on. But for now, we'll just assume we have a package assembly, and then we're interested in seeing how we could actually mount everything. Okay. So for this one here, you can see if you were to mount one of these, you have the ends here. You can see that there's these holes here that you could mount onto, and there's really a million ways you could mount this depending on your sort of application. So it just depends on what object you're mounting to. You can see here's like a screw here. You could mount that hole to some object. Here's like another example of like a linkage that's being rotated. So you could have like these sort of linkage beams that rotates. There's a lot of different ways. This one here is gonna have some sort of shaft coupling, and we'll have another videos on that as well. But for now, let's just take a quick look at one of these. So I'm gonna download this and put it in my linear actuator folder. So, as with motors, we look at RPM. With linear actuators, you typically look at the stroke length. So, you care about how much something moves back and forth. And you might be interested in what type of motor. This one here, you have to choose your own motor. Some other linear actuators like this, they might spec it out for you. And then you could just figure out how fast you want it. Maybe there's a torque rating, maybe there's a diameter you want to meet in terms of the mounting. And then you might have some electrical constraints like your voltage and your current. But probably the most important variables you'll be looking at is the load capacity, which is how much force you can be pushing and pulling. So in this case, it's 25 pounds. And then the second most important is the stroke. So here is the 4 inch. I mean, they're all very important. You have your stroke length, the amount of force, and then also um, the speed. So those three things are probably the most important aspects when you're specing that out. And then here you can see that they this one's a little bit different. They tell you how many travel per turn. You have a max speed based on the structural aspect of this. They'll have a max motor torque that you can use with it as well. So depending on your space that you're working with, you may decide to go one over the other. So if we open up one of the linear actuators, you can see this is how it looks like. So here's like a shaft coupling. Again, we'll go into shaft couplings more later on, as well as this. Uh, this is more like a ball screw here, but we'll go into that later on. But essentially, this middle block, which is like a carriage, will slide back and forth along this structure that's built up together. And then, as a user, all you got to do is choose a motor here that will mount to this face, and then you could place some object on top. Okay, so we'll just go ahead and choose the appropriate motor to see how everything fits. So this one says is for a NEMA 17 motor frame. Okay, so we want to choose if I could spell NEMA. So NEMA 17 motor. And then we'll just go ahead and choose this one. And we're gonna download this. So if we download this, we can see that let's make an assembly. Pin this, bring in our linear actuator and our stepper motor. So if I mate this to that, and then this face to that face, you see that it should mount up. Okay, and then let's mate this face to that face. Okay, so that's how you would mount it together. And if you take a look, you could see that. Okay, you can see that there's a main shaft that goes into this coupling. And again, we'll go into coupling later, but you can see how this motor is attached, and then this whole thing will spin, and then this carriage will move back and forth. Okay, so in terms of the mounting, if I do a section view here, actually, you can see how the inner workings of this is. So ideally, you need to have a block. So this block will mount to this motor. So you'll have to first remove this block off. So that's going to be the order of operations. So once this block is off, so you can see that you need to have access to this screw here. So you need to loosen these screws to release this block. And then once this block is released, we can assemble these two blocks together by adding the screw here. Okay. So we've done a lot of screws assembling with stepper motor, so I'm just going to skip that part. But you would go ahead and look at your spec sheets as we did before. If you go into your linear actuators, actually you can see it in your stepper motors. So you can see this calls for a M3 screw, so you would want to use a M3 screw to mount onto that one. And then you can also take a look at this data sheet here for more details. So you can see this block is removable, as we saw, based on these screws here. So all you got to do is release these two screws to remove this block, and then you could do your mounting. Okay, so, and then here, if you want to mount a block, you could design a block that goes on top. So for here, you could see that this block takes M5, M5 screw to mount onto something. So you could design a block that mounts on top of this. Okay, so that pretty much summarizes how to use a linear actuator. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one.